We're going to balance this using the algebraic method. First, put in variables A, B, C, and D because we have 4 chemical species. The linear equations will be based off of each atom type. We have iron, oxygen, and carbon. There are 2 irons associated with A and 1 with C. Our equal sign comes at our yields or produces arrow. Oxygen has 3 associated with A and 2 with D, and C, and carbon has 1 associated with B and 1 with D, telling us that B equals D. We're going to set one of the variables equal to 1 and solve for the rest. We choose the one that tells us the most about everything else and also has the highest coefficient associated with it. This allows us to have reasonable numbers when we go to solve them all. With this, we find out that D is equal to 1.5. We're not allowed to have halves, so we're going to double everything. In doing so, B equals 3. In doing so, D equals 3, B also equals 3, and A equals 2, and C equals 4. We're going to solve this using the wrap table method, or the trial and error seesaw method. And we're going to go ahead and set it up where we have the wrap table, reactants, atoms, products, where it's simply a balance sheet to show us what is balanced and what is unbalanced. Right now, the iron and the oxygens are the only things unbalanced. We should not balance iron first because iron appears by itself, and so it's very easy to simply put a coefficient there that would make it equal. We should go after the oxygens first, but they're at odds with each other, so we would look for a common multiple of 6. Put out coefficients that would make both sides have 6 oxygens, and then solve for the rest. Again, that is more of a trial and error because not every student is going to do that immediately. That is a learned habit and a learned behavior. We're going to go ahead and compare the wrap table to the linear equations and show that both of them are revealing the exact number of each atom type on each side, just a little differently. There are still 2 irons on the reactant side and 1 on the product side. There are still 3 oxygens on the reactant side and 2 on the product side. And there's still 1 carbon on each side. The variables and the equal sign can sometimes confuse people.